Today's lesson covers the real number system. Your notebook should already be set up with a table of contents entry and pages set aside for the real number system. So the first thing I want you to do on those pages is to make a list of as many types of numbers as you can in 2 minutes. That's all I'm going to ask of you. How many types of numbers can you list in 2 minutes? You're going to pause here, watch your time, and when you're done with your 2 minutes, come back. So in my experience, a lot of students list examples of our number sets or types of numbers. So I gave you a vocabulary page, and the sets that we are going to focus on this year are on that page that I gave you. So underneath where you just did your brainstorming, you should have your vocabulary sheet glued into your notebook. So let's dig a little bit deeper into our different number sets. When you were younger and shorter, a very little person, natural numbers were the first set that you learned about. Natural numbers are your counting numbers. And your parents were very excited when you learned how to count your Cheerios or your blocks. And so your natural numbers would be the set of numbers that start with 1, 2, 3, and keep counting up from there. Your second set of numbers are all of your natural numbers and one more. So whole numbers include the number 0 and all of your counting numbers. So that set would include 0 and all of the counting numbers as well. Your next set are integers. So when you had a number line when you were a little person, it started off with just the right-hand side of the number line. And then your teacher told you, well, that's only half of the numbers. And so she gave you a number line that looked like this and said, you can also count backwards. And so that number line involves integers. Those are your positive numbers, negative numbers, and 0. So it would be all the numbers less than what I'm writing, as well as all the numbers greater than what I'm writing. All right, so let's move on to rational numbers. A rational number is any number that can be converted to a fraction. So that number line example I just gave you for integers, it's all the in-between stuff. So it's things like decimals and fractions and mixed numbers. So if a rational number can be converted to a fraction, an irrational number cannot. And so these are the numbers that are non-terminating. That means they never stop, and non-repeating. The most famous of which is pi. It never stops, it never repeats, it is irrational. So numbers are either going to be rational or they're going to be irrational. They can never be both. So the last number set I have for you is made up of both the rational and irrational sets together make up real numbers. All right, I would have given you this graphic. We're going to go ahead and fill this in for our visual learners. We're going to start with the smallest set right here. The smallest set we have are the natural numbers. Things like the number 1 or the number 10 or the number 29. counting numbers. We're going to go one step bigger than natural numbers. The next bigger set includes all of the natural numbers and the number 0. So these are our whole numbers. We already have the natural numbers. We just have to add 0 to this set so that whole numbers are 0 and all of our counting numbers. Our next set is a little bigger yet. It includes all the natural numbers, all the whole numbers, but it also includes all the negative numbers. So we're going to call these integers. And those would include things like -2 and -19 and -10, as well as all the counting numbers and 0. And then the next biggest set is this one. And those are the rational numbers. Rational numbers are all the counting numbers and 0 and all the negatives and everything in between. So things like 25/100ths or 1/8 or 4 1/2. All of those would be rational numbers. Then separate from that would be this set. Does not include any rational numbers. This is where you would find your irrational numbers. They don't belong to any other set. They're things like pi, or this fabulous number. Oops, that's a 2. 27, 277, 2777, and so forth. Although you see a pattern, nothing is repeating exactly. So this is where our non-terminating, non-repeating numbers go. And then the umbrella that covers all of these numbers is the real number system. It involves both rational and irrational numbers. So for this next activity, I want you to name all the sets to which each example belongs. And we're going to work through the first one together. So on this, if Google Slides was more math friendly, I would have written it as this, but I couldn't get that repeater bar to work for me, so I had to write it out this way. So we're going to start with our vocabulary list. We're going to work our way through all of them, and if this fits into the set, we're going to write it down. So this is not a natural number because it's not a counting number. It's also not a whole number because it's not a counting number or 0. It's also not an integer. It doesn't belong on that number line I drew earlier. Rational or irrational, it's got to be one or the other. Because it is repeating, it is rational. We're going to learn how to change that into a fraction later on in another lesson. It cannot be irrational if it is rational, but every number I give you is real. All right, your job now is to finish these two. There are 3 on the next slide. I want you to name all of the sets to which each example belongs, and while you're working, I want you to pause and then come back when you're ready for checking. Here are the answers for these two. So we have 1/4 is rational because it can be a fraction and everything is real this year. 0 is a whole number and it's on the integer number line, and I can make it into a fraction simply by putting a 1 underneath it, so it's rational and everything is real. Same activity, last 3 examples. I wanted to give you just a little hint on this negative square root of 49. The negative is separate from the square root, so we're going to leave the negative And then we are going to evaluate the square root of 49. Square root simply means that there is a number. When I multiply it by itself, I will get 49. And so I want to get to that root number. Since 7 times 7 is 49, the square root of 49 is 7. So these are equivalent. Take this number and name all the sets to which it belongs. Then do pi, then do this. So go ahead and pause me while you work and then come back for answers. -7 is an integer. It's on that number line. I can make it into a fraction simply by putting 1 underneath it. So it's rational. Everything is real. Pi, we already know that's irrational. If it's irrational, it can't be anything else but real. And then the last example, although there's a really nice pattern going on here, it is not repeating exactly. It doesn't terminate, it doesn't repeat, so it is irrational, and everything is real. All right, last ones. Pause me while you figure these out. Come back when you're ready for checking. All right, so here are my answers. Here, not a counting number, not a whole number, doesn't belong on that number line. It is rational because I can make it -7 1/4, and everything is real. This one's a little tricky. When you use your square root key on your calculator, you're going to get this number. And then I run out of display space. So for this year, if that happens, look to see if anything's repeating, and it's not. And if it continues past what your calculator can hold, we are going to assume it is non-repeating and non-terminating, which would make it irrational. Everything is real. 1 4/5, not a natural counting number, not a whole number, not on the integer number line. I can make it into a fraction. It would be 9/5. And everything is real. And then the last one has all sorts of them. It is a counting number. It is in the set that is a counting number plus 0. It is on that number line. I can make it into a fraction just like that, and everything is real. All right, it's always, sometimes, or never time. I want you to think about each of these statements and decide, is it always, sometimes, or never? So for example, the first one, is a decimal number always irrational, sometimes irrational, or never irrational? Decide, write your answer down, and then go on to the next one. Is an integer always a whole number, sometimes a whole number, or never a whole number? While you're working, I want you to pause me and then come back for checking. All right, is a decimal number an irrational number? Well, the answer to that is sometimes. So if I give you this decimal number, well, I can make that into a fraction, and that's rational. But if I give you this decimal number, that one is irrational. So it depends. It is sometimes. Is an integer a whole number? Well, let's think about that one. Integers belong on my number line. Are all these things whole numbers? Well, my answer is sometimes. This part of my number line, yes, those are all whole numbers. But this side of my number line is not whole numbers. Okay, same deal, always, sometimes, or never. Is a whole number always an integer, sometimes an integer, or never an integer. The second one, is a negative number a whole number always? Is it sometimes a whole number, or is it never a whole number? You're going to come back after you've paused and done your work for checking. All right, whole numbers. 0, 1, 2, 3, blah, 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 until infinity. Would those belong on the number line? They always do. A whole number is always an integer. And then a second one, is a negative number a whole number? Well, again, here are my whole numbers. I don't see any negatives, so that is never. All right, we are all done with the lesson. Congratulations.